Hey everybody, today's video has a fairly limited audience. This will be of interest to you if you are a contributor to the Zulip project and you're writing JavaScript code. Zulip is very good about unit testing their code, both on the JavaScript side of things for the client and on the Python side of things for the server. But this video is going to be focusing on the JavaScript side of things. And I think the most important thing that you want to do when you start contributing and you need to write tests, I mean, there are several things you should do, but the first thing that you should do is go to the Zulip developer documentation. And the developer documentation is pretty clear. It's not like the most thorough of Zulip's documents, and I'll explain why that is in a little bit. But essentially what we do is we try to actually show how to use the unit testings by example instead of by documentation. But there is like some very good documentation to kind of get you oriented. It says here like the node-based unit test systems are indeed the preferred way to test JavaScript and TypeScript code in Zulip. It's preferred over the Puppeteer black box whole app testing because it's a lot faster. And that is true. And I don't want to dismiss Puppeteer because I really do think that for certain testing paradigms, Puppeteer is the right way to go. But a lot of Zulip code is very data oriented in nature. And if you can get the data oriented functions very solid and reliable, then of course that makes solving more difficult UI problems easier because you're working on a good foundation. So this is an example test where we really just like use a data structure and make sure that the data structure is doing the same thing. But you can read the rest of this documentation and I think it'll give you a good orientation. But what I really recommend to people, especially if you're the type of person that kind of just like learns by pattern matching, which I think applies to most people, then you want to take advantage of the fact that in the repo, there are 8 tests that are not only actually testing the code, like if these tests fail, that means something's wrong and the test will break and that'll prevent us from pushing, bad code to the repo. But these are really intended to be examples, hence the names. And they were structured, these were all mostly written by me. These are all intended to just like gradually build up the concepts in the node testing ecosystem, I guess. So the first example is just example1.test.js. As you can see, it's like fairly heavily commented. And I'm not going to read every comment to you because I don't think that would add much value, but I will sort of highlight some things. So, at the top, there's always a little bit of boilerplate at the top of the files, but it's relatively simple. In almost every test that you write, I would be shocked if there are any tests that don't do this. You're going to make assertions about things. And one of the reasons that this system was originally implemented in Node is that Node basically provides like a decent assert library right out of the box. So you require that explicitly, and then this Z-require is something that you need in order to pull in other code, and it's just like Zulip's flavor require. And then this run test helper is extremely important, as you'll see further down. And then we start actually using Z-require to pull in actual Zulip code. So there's a Zulip module called people.js, or might be people.ts now, but it basically just like that has helper functions that are all related to like the most fundamental object in, or arguably one of the most fundamental objects in Zulip, which is like a user. Okay, so then down here we start making basic assertions, and you'll notice here that I don't even bother to put them inside of a run test wrapper. I just make an assertion that says If you use the util function to find wildcard mentions and you pass in boring text, then it's going to assert that that's false because there are no wildcard mentions. Whereas here you can see this is a wildcard mention mentioning at star star everyone star star. And then we go down and we start testing some things about people. So Isaac here is Isaac Newton. You'll see in the test that there are like, I don't know, like 5 different ways of like naming users. Like there's definitely like some, they're like scientists and mathematicians. I think there are Simpsons characters at some point. There are definitely Shakespeare characters. So you'll see different themes for coming up with fake usernames. Not that Isaac Newton was fake, but you know what I mean. And as I say it, I mean, this comment echoes what I said before I even read it. The people object is an extremely fundamental object in the Zulip app. And you can learn a lot by reading the tests in people.test.js. And I should show you how to do that. It's very simple. You just go into the test directory, Zulip web tests. And if you go down to people.test.js, that test suite's like over 1,000 lines. So that's like, you know, it's a lot to read, but it's like, it's really straightforward. Like the first couple hundred lines are just kind of setting up users, and then you kind of really get into the meat of the test. But this is like a really great module where, you know, just brew a pot of coffee or tea or whatever your favorite drink is, and just like sit down and kind of read through it, and you'll like quickly observe a lot of patterns. But getting back to example test 1, after I demonstrate how to call assert OK with a couple functions from the people module, I go right into the streams. And I mean, if you're contributing to Zulip, you probably already know that a stream is just like a Zulip's nomenclature for a channel. And streams are also obviously extremely important to a chat app and to the Zulip code base itself. So we create this Denmark stream, and this stream's not necessarily like completely exhaustive or representative of like the actual data that's stored in a Zulip stream, but it's good enough for the purpose of testing. And so this whole module, example 1, by the way, is only 73 lines of code. And so like this is a good thing to just like really read carefully, because by the time you're done reading this, like you're probably going to be able to modify unit tests with some degree of success, unless you're fixing like a more complicated UI related feature. But if you're just like modifying something that's like data related, then you should be able to observe the patterns. So let's go to example 2. Let's see what happens in example 2. Okay, so example 2 is just like basically pulling in some more Zulip objects. So we, I mean, again, it's like the most important things in Zulip are people, which is just the users, streams. So we have stream data, and we have stream topic history, and of course messages. So for example, message store is like a really fundamental piece of code in the Zulip client, because anytime you want to display a message or retrieve a message from the server, then you go to the message store to pull out the message. And again, you can kind of see the pattern here. The general structural pattern is that you've got some requires at the top. Again, we pull in assert, we pull in zrequire, we pull in run test. Like these first 6 lines here are very boilerplate, and then you pull in actual Zulip objects. So you do zrequire, 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 zrequire. By the way, if your unit test is like using zrequire in like 15 different modules, then that's an obvious code smell that you might be working with a module that could be decomposed a little more, or that you're trying to be too ambitious in your tests. But this level of granularity is fairly typical, because it is within the purview of the no test to test interactions between objects, as well as testing that the objects themselves kind of work independently. Um, okay, and then after you do the Z requires, then the next chunk of code is usually just like setting up data. And then finally you get to the run tests. So every test starts with this like little run test helper. Run test takes two arguments. It takes a string, and that string is literally just for display purposes, so that when you run the test, it'll say running test message store. And then the second argument is basically an anonymous function that actually gets run by run test. And so let me read the second test. So we're testing, let's see, tracking unread message is a very fundamental part of the Zulip app, and we use the unread object to track unread messages. So we declare bankruptcy, which is like kind of a, for the purpose of the test, all we're doing is clearing out the unread data. I don't know if you've ever run into bankruptcy as a Zulip user, but if you have like a whole bunch of unread messages and you want to kind of get a clean slate, then you do what's called declaring bankruptcy, and that basically like sets all of your messages to look like you have already read them. And the reason that you declare bankruptcy as a user is that once you declare bankruptcy and you have no unread messages, then you can come back to the app 2 days later and you can see what actually is new. So then we also clear subscriptions. We add a sub, and a sub is just a subscription to a stream. So we add a subscription to the Denmark stream. We get the ID of the Denmark stream. We get the topic name. So, you know, topics are like, streams and topics are sort of a hierarchy. So like the Denmark stream could have several topics. One of them would be Copenhagen. I don't know. Maybe the other would be cheese. I don't know. Third one might be bicycles. I've been to Denmark for a total of 24 hours in my life. So I apologize to the people of Denmark if I'm sort of being silly about like what would be in a Denmark stream. So okay, and then like this is the first thing that's actually like a test or that is testing an assumption that you have about the code. So it says that we are asserting that the number of unread messages for the topic, for stream ID corresponding to Denmark, and for topic name of Copenhagen, we assert that we have 0 unread messages. And then what happens here is you get this in message, and I'm not, let's, I guess that's like short for incoming message. I would probably rename that variable if I had a little bit of time. But okay, so we, in the message store, we set the message booleans for the in message. And I guarantee you that the interesting thing about this message is that it probably is somehow not read. And I'm not sure if that's going to be implicit or explicit, but let's see. If we come up here, oh yeah, so okay, so it has the flags, has alert word, but it does not have the red flag, READ, not the color. So I think when we get down here, we process loaded messages, and now when we count the number of unread messages for the topic, of course we get 1, because that message that was introduced into the message store is not read. So now we've covered example 2, and again, like most of these examples are less than 100 lines, or like at least in the ballpark. So you can kind of sit down and like, you know, really read it carefully. Like I would, especially for the first 2 examples, if you just take your time and read those, I think you'll get the gist of what's happening. And yeah, here again, this example is less than 97 lines, and it's kind of the same pattern again. All this stuff up here is basically boilerplate. We say use strict, and that's saying that we want JavaScript to be interpreted in a strict fashion. And then we require assert, and then this strict is sort of unrelated. I mean, it's the same concept, but it's sort of unrelated to that. but we're asking Node to give us the assert library using kind of stricter semantics. And I don't want to go too deep on that because I actually don't know all the details. Excuse me. But then we require z require, and we pull in z require by requiring lib namespace. We pull in run test by requiring lib test. And then we pull in page params. And page params is kind of a special concept in Zulip because page params is this like fairly gigantic data structure that gets sent down in the payload to the client. And it's kind of like, I don't want to call it a kitchen sink because that sounds a little derogatory, but it is like a kitchen sink of just like useful information for the client app. And then we start pulling in other Zulip objects. So we've already seen the stream data module in I think both of the prior examples, but definitely example 2 if I recall correctly. And then this filter. So a filter object is what Zulip uses to filter messages. So in the Zulip app, like you see all of these messages, like not only stream messages, but also direct messages, otherwise known as private messages. But when you're in any particular view, the stuff that you see is going to be filtered. Okay, and so here I say this is the first time we have to deal with page params. Page params is a lot of important data shared by various modules. That's 100% true. And most of the data is irrelevant to our tests. But we do use this here to explicitly say that we're not a special Zephyr realm, since we want to test the normal code path. And I can go down a little rabbit hole talking about Zephyr, but that's not like super important. I think the thing that you want to glean from reading these tests is just the overall structure. And here, in order for a test to work, we just had to set this particular Boolean variable to false. But then we get down here and, you run the test, and the test clears some data, sets up some data, sets up some filter terms, creates a new filter object, creates a predicate, and then it makes an assertion about the predicate that, let's see, we don't need full-fledged messages to test the gist of our filter. If there are details that are extracting from your test, you should not feel guilty about removing them. So basically, like the way a predicate is supposed to work is that you pass in something like type personal, and why am I struggling with this concept? Because I used to work on this code. I think it'll be more clear when we see the next thing. So let's see, where's the? Oh, okay. I know I'm struggling with this because I didn't really read the. I didn't follow my own advice. You want to read every line of the code fairly carefully. So when you make a filter, you base it on filter terms, and essentially, like the cool thing about the filter is that it automatically makes a predicate function that's like a way to test things. And I don't know if like predicate's the best word for it, but I think it kind of makes sense. But at any rate, so the filter terms here are that you need it both the stream to be Denmark and the topic to be Copenhagen. And so when I call with type personal, of course that predicate's going to fail because I'm not even using like the right type of message. Like this filter expects stream-based messages. So of course when I pass in a personal message to it, that predicate's going to return false. And then here I have a topic that doesn't match, so that predicate again returns false. But then finally down here, I pass in a message with all the right data. It is in fact the type of stream. The message type is in fact a stream message, is a slightly more precise way to say that. And the stream ID corresponds to Denmark, topic corresponds to Copenhagen, and that returns true. So I think I'm going to stop there for now. I will, let's see, we've gone through like about 2.5 examples here. And in a follow-up video, I'll go through some of the more complicated examples. But I think even after like reading the first 3 examples, you can kind of get the gist of the overall structure of all these files. There's a little bit of boilerplate at the top. It's important for almost every test that you pull in: assert, z-require, run test. In this particular thing, we require page params, which is kind of a special thing within Zulip. Then we pull in the modules that we need. We set up some data, and then we get down to the actual tests, which are always run with this run test helper. Okay, so I hope that helps you get started. And as I said, if people like this, hit the like button, and that'll give me incentive to cover the next 5 examples, which do get a little more complicated. So anyway, good luck with reading these first 3, and I hope this was helpful. Thank you.